Welcome back, everyone. Today we're going to talk about the characteristics of graphs. We've already talked about a lot of these, like domain and range and things like that, but we're going to get all the ones we haven't talked about. We're going to talk about them in terms of parent graphs, but we can talk about them with any graph. So, characteristics of a graph. Every graph has certain characteristics. We've already discussed some of these, like domain and range, but we have many more to talk about. Graphs with the same parent function will have similar characteristics. This is why we study parent functions at the beginning of the year. By knowing what we start with, then we can talk more about the functions as we go along. Each transformation will change some of the characteristics of the parent graph. Let's talk about the ones we already know. We've talked about domain and range a lot. Domain is how far the function goes left to right. Well, what can affect domain? Any transformation that moves it left and right might affect the domain. It doesn't have to, but it might. And range is how far the function goes down to up. Transformations that might affect that are when you move the function up or down, or when you flip it. It doesn't have to, but it might. What other characteristics have we talked about? We've talked about the y-intercept. This is where the function crosses the y-axis. You guys have talked about y-intercepts a lot. Any of the transformations can affect the y-intercept. So we have to keep that in mind. And the x-intercept. This is where the function crosses the x-axis. We also call these zeros or roots or solutions. And all of the transformations can affect the x-intercepts as well. So those are the four that we've really talked about that you should have seen before. We've kind of talked about increasing and decreasing, but I want to spend a little bit more time practicing them. Read the function from left to right, just like you would a book. Determine if the function is going up, it's increasing, or going down, where it's decreasing. Label these using only the x values. That is the most missed problem on this section. People want to use the y values. We only label with x values. If it helps, think about a car driving left to right. Are you going uphill or downhill? If it goes from up to down, from that point up top is a maximum. If it goes from down to up, that point at the bottom is a minimum. So let's take an example here. Let's talk about the increasing, the decreasing, the max, and the min. And it always helps if you put a little negative infinity over here and a positive infinity over here, because we know that we start with negative infinity and we end at positive infinity. So my graph goes increasing to this point, decreasing to this point, and then increasing for the rest of the way. So now let's split that up. Well, what x value is this point? It's -5. And what x value is this point? It's 1. So my first interval is increasing. How do I write the interval? From negative infinity to 5. I'm not going to count -5 because it's not increasing at -5. It's changing directions. And then it's decreasing. How do I say where it's decreasing from and to? Well, it starts decreasing at -5 and it stops decreasing at 1. It's -5 to 1. And then it's increasing again. It starts increasing at 1 and it goes all the way to the right side, which the right side is infinity. So notice that it's negative infinity to something and then something to infinity. You have to have every point in there. It's got to hook together. What about maxes? Where's a max on the graph? Well, this point's a max. It's where it's a little mountaintop, a little peak. So we say that x equals -5 is a maximum point. Where's there a minimum? Right here. This is a little valley, a bottom. So we call x equals 1 a minimum in this problem. Let's try one that's a little bit more difficult. Let's try one that has asymptotes in it. So, again, if it helps, put a little negative infinity over here and a positive infinity over here, and let's read it left to right. This side is increasing, and then it's decreasing to this point, which is 3, and then it's increasing again. So let's write this out. It starts increasing from negative infinity to this asymptote. This asymptote, it stops increasing. Well, what's the asymptote? -2. Then it decreases from -2 to 3. Then it starts increasing again from 3 on over to the right side, which means 3 to the right side is infinity. What about a maximum? Well, people have some trouble with this. It goes up and then it comes down. But because there's an asymptote there, the graph never actually meets together in a point. There's an asymptote, so they never quite touch. There's never a point on top. So there is no maximum in this graph. But there is a minimum. Right here, this is a little valley. It's one point that's at the bottom. So I can say that x equals 3 is a minimum. A little bit tricky because of the asymptotes. Let's talk about symmetry. Symmetry is pretty easy. There's two types. You need to be able to recognize both from the graph and the equation. Even symmetry. Even symmetry is also called y-axis symmetry. It means the graph is symmetric to the y-axis. People are generally even symmetry. If you drew a line right down the body, they're the same on both sides. If you folded them in half, they would look the same. That's even symmetry. Algebraically, this happens when x and negative x make the same equation. So let's talk about that real quick. People have some trouble with this. How can x and negative x make the same equation? I'll give you a very easy example. What's x squared? Well, that's easy. That's x squared. What's negative x squared? Well, if you square a negative, you're going to get back to a positive. Look, whether it's positive x or negative x, by squaring it, I get the same answer back. That's an even function. If we have even functions, then we have odd functions. Odd functions are called origin symmetry. That means the graph is symmetric about the origin. If you rotate the graph upside down, it's the same as the original graph. Paper helps here. Look at your graph, turn your paper upside down. Is it the same graph? Algebraically, this happens when x and negative x make opposite equations. An example of this would be x to the third power and negative x to the third power. Well, what is x to the third power? It's x to the third power. What about negative x to the third power? Well, I have 3 negatives. The first 2 negatives will make a positive, but the next negative will turn it back into negative, so it's negative x cubed. This is an odd function. And positive x and negative x give me opposite answers, so it's odd. Let's talk about these, even, odd, or neither. This first one, if I folded it in half, would it be the same on both sides? No, so it's not even. What if I rotated this thing upside down? Would it be the same graph? Yes, this graph is odd. Number 2, is it even? If I fold it in half, is it the same on both sides? Yes, it is. It's even. Number 3, what about a graph that looks like this? If you rotated this graph 180 degrees, would you get the same thing? You sure would. It's odd. Let's take a look at this one. If we fold it in half, do we get the same? No, because there's nothing on this side. If we rotated it 180 degrees, would it be the same? Nope. This is neither. In behavior. People have trouble with this not because they don't understand it, but because they have trouble writing it. So let's take a look at how to write it. What are the y values doing on the left and the right ends of the graph, or are they going up and down forever? So I don't care what's happening in the middle of the graph. I want to know what's happening on your left side, way out here, and way over here on your right side. And I'm looking at the y values. Most students understand in behavior, but they have a hard time writing it at first. Every in behavior problem is written like this. As x goes to negative infinity, then y goes to blank. As x goes to positive infinity, then y goes to blank. And you fill in the blanks. Now that looks confusing, but if you think about it, it makes sense. What side of the graph is x goes to negative infinity? That's the left side. What side is x goes to positive infinity? The right side. So another way to think about it would be to say, as you go left, The y values go up, go down, or go close to a number. As you go right, then what does the y values do? Let's try one. Okay? Let's start off with the same thing every time. As x goes to negative infinity, y goes to blank, and as x goes to positive infinity, y goes to blank. Now let's fill in the blanks. As x goes to negative infinity means left. What's the left side of the graph doing? It's going up. How far? Forever. As x goes to positive infinity means right. What's the right side of the graph doing? Going up forever. So there's your end behaviors. Let's take a look over here. X goes to negative infinity, y goes to, and x goes to positive infinity, y goes to, and now let's fill in the blanks. As x goes to negative infinity, so the left side, what's the left side doing? It's going up forever. What's the right side doing? It's going down forever. Let's take a look at this graph. As x goes to negative infinity, y goes to blank. As x goes to positive infinity, y goes to blank. Well, let's go left. As you go left, what are you doing? You're going up, but you're not going up forever. You're getting closer and closer and closer to this imaginary asymptote. So what number is that asymptote that you're getting closer to? 1. How about the right side? What's the right side of the graph doing? It's going down forever. And then number 4 over here. Start off the same way. As x goes to negative infinity, y goes to blank. As x goes to positive infinity, y goes to blank. Both the left side of this graph and the right side of this graph are getting close to a number. Well, what number are they getting close to? They're getting close to the asymptote. What number is the asymptote? -2. So sometimes the graph goes up forever and down forever. Sometimes the graph goes down forever but gets close to a number on one side. Sometimes both sides get close to a number. You just have to pay attention to what you're looking at. And that does it for characteristics. We'll talk about characteristics throughout the whole year. They're all over the SOL. So become friends with them. You're going to see a lot of them this year. If you have any questions, please come talk to me. We'll practice them a lot. Thanks.